friends, now I am with you the second colligative property, that one is called as the depression in freezing point. Why I am taken this colligative property before the problem of elevation in boiling point, because we complete simultaneous problems based on the elevation in boiling point and depression in freezing point. So, see here the next colligative property, that one is called as the freezing point depression or depression in freezing point. My dear friends, the important things related to this phenomenon, listen, what is the freezing point, what is the meaning of freezing point depression, or we people say this is called as the depression in freezing point. Listen very carefully, like the boiling point, you know how to define the boiling point, the temperature at which the vapor pressure of liquid become equal to the atmospheric pressure, that one is called as the boiling point. You know boiling point of solution is always higher than the boiling point of pure solvent. Why? Because the vapor pressure of solution is always lower than that of the pure solvent, and it requires the more temperature to vapor pressure of solution become equal to the atmospheric pressure. So, all this phenomenon we considered here, and that one is very important to you. Now, I am going to discussing with you what is the meaning of freezing point depression. So, before going to discussing the freezing point depression, my dear students, you must know what is the meaning of freezing point. Once if you know the freezing point, then remaining thing becomes very simple to you. So, if we try to define the freezing point, very simple definition, the temperature at which liquid freeze or liquid state converted into solid state, that one is the freezing point. But actual definition of freezing point is like this: the freezing point of a solution is defined as, or the temperature at which the vapor pressure of solids is equal to the vapor pressure of liquid. So, listen very carefully, the freezing point we define like this way, the freezing point we consider like this phenomenon, because this is a very simple and very normal things related to this concept. The freezing point of a solution is defined as the temperature at which the vapor pressure of liquid become equal to the vapor pressure of its own solid, It means whenever the vapor pressure of liquid become equal to the vapor pressure of its own solid, then this is called as the freezing point or freezing point. Now, dear friends, so what is the meaning of freezing point depression? It is also called like the delta TF. This is called like the delta TF, like delta TB, delta TF. Suppose for example, once again we are considered this is the pure solvent. Suppose for example, this is the pure solvent and this is the solution. You know, the vapor pressure of pure solvent is the P0, vapor pressure of solution is the P. The freezing point is T0, freezing point of solution is T. Okay. So, my friends, what is the important aspects are related here? Which are the important aspects related to this phenomenon? The important aspect related to this phenomenon is like this. Suppose for example, as per consideration, see toward the board. Suppose my friends, suppose here. Suppose for example, this is the vapor pressure phenomenon, and if we consider this is the vapor pressure of pure solid, Okay. Now, what happened? This is the P0 now, this is P0, P0 means what? Vapor pressure of pure solvent, because vapor pressure of pure solvent is always greater than the vapor pressure of solution. This is P0, and my friend, this is P. What is the meaning of P? P is called like the vapor pressure of solution. So, what is difference between P0 and P? P0 is the vapor pressure of pure solvent and P is the vapor pressure of solution. You know, vapor pressure of solution is always lower than that of the vapor pressure of pure solvent, because in solution we added non-volatile solute. Now, due to addition of non-volatile solute, the vapor pressure of solution decreases, you know, in previous videos. See, now friends, what happened? What is the meaning of freezing point of this pure solvent? This is the freezing point of pure solvent, because vapor pressure of solvent is must be equal to the vapor pressure of its own solid. So, this is called like the T0. What is the freezing point of solution? Now, this is the freezing point of solution. This is called like the T. And what is difference between T and T0? It is called like the delta TF. It means that what's happened? The value of T0 is always greater than the T. Now, here value of T0 is greater than T. What is T0? T0 means what? Freezing point of solution. Obviously, freezing point of solution, that is T0, and freezing point of solution is T, and freezing point of pure solvent is what? T0. So this is T, this is T0. But you know, freezing point of solvent is always greater than the solution, therefore T0 is greater than the T. So this is the minor conclusion. So my friends, what's happened here? Therefore delta TF is equal to T0 minus T, because in delta TB we are considered T minus T0 now, because what happened in elevation in boiling point? The boiling point of solution is always greater than the boiling point of pure solvent due to lower vapor pressure, but here freezing point of solution is less than the freezing point of pure solvent due to presence of the non-volatile solute. That's why delta TF, that is depression in freezing point, is equal to the difference in freezing point of pure solvent and the freezing point of solution. Therefore delta TF is equal to T minus T0. Once again dear students, what's happened here? Once again the same concept we considered, the same concept, what? Delta TF is directly proportional to the delta P, obviously na, as lowering of vapor pressure increases, the depression in freezing point also increases, like elevation in boiling point increases, because as this difference increases, because you know delta P is nothing but what? P0 minus P. Delta P is nothing but the P0 minus P. So these are the very interesting concept related to this phenomenon. Now dear friends, which are the important aspects? Now I am explaining this concept by using the graphical representation. See toward the board, which is a graphical representation I am representing in front of you. Suppose you consider here, this is the vapor pressure and this is the temperature, okay, vapor pressure and temperature. Now what happened in this case? Suppose we have three cases, which is the three cases. So this is the vapor pressure, one is the P, that one is called as the then PO, this is the PO and this is the PS. PS means what is the meaning of PS? PS means vapor pressure of this solution. Listen, as all you know very well, this is a very interesting graphical representation which I am representing in front of you. So which are the graphical representation I am representing in front of you? Listen, see here. So what happened here? So these are the very simple concept or very simple things related to this phenomenon. So as per my idea, so listen, now what is the meaning of freezing point? Listen, a liquid freezes or solidified temperature at which the liquid and its solid can coexist in equilibrium. Obviously, when liquid and solid phase are in equilibrium, then at that time we people say that one is called the freezing point. Such condition is obtained when the vapor pressure of solid and liquid are equal. Obviously, na, vapor pressure of liquid must be equal to the vapor pressure of solid. Hence, the freezing point of a liquid is a temperature at which the vapor pressure of solid is equal to the vapor pressure of liquid. Now dear friends, listen, another direct consequences of the lowering in freezing point. Why freezing point lowers? Because when non-volatile solute added in the volatile solvent, then vapor pressure of solution will be decreases. So the already vapor pressure of solution is less, and this is a vapor pressure of pure solid, because vapor pressure of pure solid is also less. Therefore, whenever we discussing the phenomenon by considering this freezing point depression, okay, I will explain you next. See it on this. So delta TF is equal to T0 minus T. Why T0? Because it requires it releases more heat or more temperature to vapor pressure of pure solvent must be equal to the vapor pressure of its own solid. But vapor pressure of solution is already less, it not releases the more heat to its vapor pressure. Listen very carefully, I will explain you in another language, my friends. Listen, suppose for example this is a solvent, because vapor pressure of solvent is at this stage. Obviously vapor pressure of solution is less, and this is the vapor pressure of its own solid. Now this is the vapor pressure of solid. So when vapor pressure, these two vapor pressure become equal, then this is T0 na, and obviously solvent releases more heat to its vapor pressure converted into equal to the solid. This one is called as the T0, and this is called as the T. Now what is the meaning of T? This is called as the vapor pressure of solution. This is T0, this is the T. Okay. Now which are the important aspects related to this phenomenon? So T0 is always greater than T na, T0, therefore T0 is always greater than T. So delta TF is equal to T0 minus T, or delta TF is directly proportional to the delta P. Delta TF is directly proportional to the delta P. So this is the consideration related to this concept, my friends. Now listen very carefully. Now what is the final conclusion? Again, how we calculate the molecular mass? Therefore again delta TF is directly proportional to the M. M is called as the molality, which we are already discussed in the elevation in boiling point. Delta TF is directly proportional to what? M. So now my friends, this becomes the delta TF is equal to Kf into M. So what is mean of Kf? Kf is nothing but the molal depression constant. Kf is molar depression constant, or this is called as the cryoscopic constant. This is called as the what? Cryoscopic constant, because Kb is the ebullioscopic constant, but Kf is called as the cryoscopic constant. So what is the definition of Kf? The depression in freezing point are produced for 1 molal solution. If the value of M is 1, then delta TF is equal to Kf, or the M is also defined as the depression in freezing point are produced by dissolving 1 mole of solute in 1000 gram of solution, by dissolving 1 mole of solute in 1000 gram of solution. So that one is called as the Kf. My friends, you know formula of M is equal to what? M is equal to W2 into 1000 divided by M2 into W1, and this W1 in must be gram. Therefore, put the value of M in above equation. Therefore, delta TF is equal to Kf into W2 into 1000, Kf into W2 into 1000 divided by M2 into W1 in gram. Therefore, delta TF is equal to, my friends, now we calculate the molar mass of this particular solute. Therefore, how we calculate the molar mass? Therefore, M2 is equal to Kf into W2 into 1000, Kf into W2 into 1000 divided by delta TF into M2 into what? Delta TF into M2 into W1. So this is the very simple phenomenon. I am sorry, delta TF into what? W1, because M2 were already taken here. Now what is delta TF? Delta TF is nothing but what? TO minus what? TS. We consider delta TF or sorry, delta TF or TO minus T. What is TO? TO is the freezing point of solution, and what is freezing point of pure solvent, sorry, and what is T? T is the freezing point of what? T is the what? Freezing point of pure solution. Okay. So these are the way, by using this we discuss the depression in freezing point. Now I am going to discussing with you the problem related on depression in freezing point and problem related to this phenomenon, that is depression in freezing point as well as elevation in boiling point. Okay. Because in previous videos I am already completed elevation in boiling point. Now these are the two formulas, by using that we always keep in your mind, because these are the very standard formulas. Which is that formula? You know very well, delta TB is equal to KB into M, or delta TB is equal to KB into W2 into 1000 divided by M2 into W1 in what? Gram. M2 into W1 in gram. That is delta TB. Same things happens here. If depression in freezing point is there, here delta F and here Kf. Now, so I will give you the problem related to this phenomenon. Now, write down the second problem. Calculate molality of solution of a substance which on dissolving. Listen, write down the problem. Calculate molality of a solution of a substance which on dissolving, molality of a solution of a substance which on dissolving in benzene, which on dissolving in benzene, listen very carefully, which on dissolving in what? Which on dissolving in benzene, boils at 353.71 Kelvin. Benzene boils at 353.71 Kelvin. Kb for benzene is 2.53 Kelvin kilogram per mole. Kb for benzene is 2.53 Kelvin kilogram per mole, 2.53 Kelvin kilogram per mole. You know the unit of Kb, per mole. And boiling point of pure benzene is, and boiling point of benzene is C6H6 means benzene is, how much boiling point they are given is 353.35 Kelvin. So this is the problem. Sometimes such type of problem they ask you in examination. So dear friends, what is the problem? calculate molality of a solution of a substance which on dissolving in benzene boils at 353.71 Kelvin. Kb for benzene is 2.53 Kelvin kilogram per mole and boiling point of benzene is 353.35 Kelvin. Okay. So what's happened here? You know, the calculate the molality, they are asking you to calculate the small m, that one is called as the molality, which on dissolving in benzene boils at, they are given to you boiling point of solution, that is 353 boiling point of solvent, listen, and boiling, they are dissolving in benzene boils at, obviously this is a boiling point of solution 353.71 Kelvin. Boiling point of pure benzene they are given, that is 353.35, because this is elevation in boiling point. Now, obviously boiling point of solution is always greater than boiling point of pure solvent, and they are given to you the Kb. What is the Kb? Value of Kb is 2.53 Kelvin kilogram per mole. This is a value of Kb. So, dear friend, calculate the molality. As you know very well, the formula which is present in front of you, delta Tb is equal to Kb into m. So, my friend, so m is equal to, you rearrange this equation, m is equal to, how we rearrange? M is equal to delta Tb divided by Kb. So, this is the rearrangement form we consider for this equation. Small m is equal to what? Delta Tb divided by Kb, small m is equal to. Therefore, also we say small m is equal to, what is delta Tb? Delta Tb means T minus TO upon Kb, because boiling point of solution is always greater than solution. Therefore, small m is equal to, what is the value of this? And T, what is the value of T? T is equal to 353.71 minus value of T0 is 353.35 divided by, what is the value of Kb? The value of Kb is 2.53. Therefore, small m is equal to, 353.71 minus. So, after considering this, so 0.36 divided by 2.53, this value become the 0.36 divided by 2.53. What is the unit of 0.36? Unit of 0.36 is a Kelvin, yes or no? And what is the unit of this? Kelvin kilogram per mole. Obviously, Kelvin get cancelled, get cancelled, because unit of molality is mole per kilogram, obviously, or kilogram, mole per kilogram. So, listen very carefully. So, what it become? Therefore, small m is equal to, you divide this, and after consideration this 0.11423 mole per kilogram. So, this is the unit of molality. My friends, this is a very simple problem. By using this, we calculate the molality. Everything is there given in the problem. Just to put the value of that given quantity in your formulas, and finally you got a very easily answer of this question. Now, we are moving toward the second problem. Write down in your notebook. So, which is the second problem related to this phenomenon or related to this concept. My friends, these are the very simple things related to this. Now, the second problem is like this. A solution is prepared by dissolving. Listen, a solution is prepared by dissolving. By what? Solution is prepared by dissolving. Listen, by dissolving 1.9 into 10 raised to minus 2 kilogram of ammonia, 1.92 into 10 raised to minus 2 kilogram of what? 1.92 into 10 raised to minus 2 kilogram of ammonia in 400 gram of water, kilogram of ammonia in 400 gram of water, kilogram of ammonia in what? 400 gram of water. Calculate elevation in boiling point, calculate, see here, calculate elevation in boiling point, calculate elevation in boiling point boiling point. If Kb for water is, if Kb for water is, they are given Kb for water is 0.52 Kelvin kilogram per mole. Kb for water is 0.52 Kelvin kilogram per mole. They are given to you Kb, and they are given the formula of ammonia. You know very well. See, a solution is prepared by dissolving 1.92 into 10 raised to minus 2 1 kilogram of ammonia, 1.9. Okay. So dear friends, they are given mass of solute W2 is equal to 1.9 into 10 raised to minus 2 kilogram. Obviously they are given the mass of solute. Then what is the molar mass M2? You know this is ammonia na. Now, how to calculate molar mass? Nitrogen 14 plus 3, that is 17 gram, means what? 17 into 10 raised to minus 3 kilogram, because if they are given weight in kilogram, just to consider the molar mass in also kilogram, because if, to balance the unit, okay. So molar mass in 400 gram of water, they are given W1, value of W1 is how much? This is 400 gram, obviously. And then finally calculate the elevation in boiling point. They are asking you to calculate the delta TB, because elevation in boiling point. If Kb for water is, they are given to you Kb for water, that is 0.52 Kelvin kilogram per mole. So this is the Kb for what? This is the Kb for water. Now friends, now I am going to discussing with you, this is a very important phenomenon. So what is the formula present in front of you? Delta TB is equal to Kb into W2 into 1000, Kb into W2 into 1000 divided by what? Divided by M2 into W1 in kilogram, W1 in gram, because we are taken the 1000 here. So put the value of all these things. Delta TB is equal to, what is the value of Kb? Value of Kb is 0.52 obviously, and then into what is the value of W2? The value of W2 is 1.9 into 10 raised to minus 2 into what? Into 1000, yes or no? Divided by what? Is divided by M2. What is the value of M2? The value of M2 is 17 into 10 raised to minus 3, because this is in kilogram, therefore this is in also kilogram. Then into what is the value of W1? That is 400 gram, because we considered here 1000, therefore we taken the value in gram. So my friend, the value of delta TB become the value of delta TB. This is a very simple phenomenon. The value of, by putting all these things, the value of delta TB become 1.45 Kelvin. Therefore value of delta TB is equal to 1.45 Kelvin. So this is the very simple way. Or I will give you some another way also how to calculate this problem. Or you first calculate molality, because when we calculate molality, formula of molality is M is equal to W2 into 1000 divided by M2 into W1. This is a formula to calculate the molality. Once you calculate the molality, then put the value of molality, because they are given to you Kb. So how to calculate the molality? Therefore small m is equal to, the value of W2 is 1.9 into 10 raised to minus 2 into what? Into 1000 divided by 17 into 10 raised to minus 3 into 400. Yes or no? This is get cancelled, okay. So finally my friends, so this value become, after putting all these things, the value of this become the m is equal to 2.794 mole per kilogram. So this is the value of m. M is called as the molality. Now my dear friends, after calculating the value of m, then we calculate the value of Kb. Delta Tb is equal to Kb into m. Obviously delta Tb is equal to, what is the value of Kb? The value of Kb is 0.52 into value of m is 2.794, 0.52 into 2.794, and then after calculating this, the value of delta Tb is equal to 1.45 Kelvin. So this is the nothing but elevation, the problem based on elevation in boiling point. Write down in your notebook, my friends. As per my idea, you don't have any problem related to this phenomenon. Now come to the third problem, a solution containing 1.21 gram of camphor. Listen, now we are moving toward the next problem of this topic, which is the next problem. See toward the board. Next problem. See here, next problem. A solution containing 1.21 gram of camphor. Solution containing 1.21 gram of camphor. A solution containing 1.21 gram of camphor. Molar mass 152 gram per mole. They are given the molar mass of camphor. Molar mass. What is the molar mass? 152 gram per mole. Molar mass is 152 gram per mole. This is the molar mass of this camphor, 152 gram per mole. in 26.68 gram of acetone. In what? In 26.68 gram of 26.68 gram of acetone. Yes or no? 68 gram of acetone, 26 gram of acetone boils at 329.95 Kelvin. Acetone boils at 329.95 Kelvin. Obviously 329.95 Kelvin. The boiling point of pure acetone is the boiling point of pure acetone is, my friend, see here, the boiling point of pure acetone is, listen, is 329.45 Kelvin, is 329.45 Kelvin, 329.45 Kelvin. Calculate molar elevation constant for acetone. Calculate what? Calculate molar elevation constant. Molar elevation constant for what? Molar elevation constant for acetone. So this is the very simple way. By using this we calculate the molar elevation constant. How we calculate the molar elevation constant? Listen very carefully. This is a very simple things related to this phenomenon. My solution containing, they are given weight of camphor W2 is equal to 1.21 gram. Molar mass they are given. Therefore, M2 is equal to 152 gram. Obviously, na, both are in gram. Therefore, no need to take into 10 raised to minus 3. So, in 26.68 gram of acetone, they are given the weight of solvent. W1 is equal to 26.68 gram. Boils at, they are given the T, that is boiling point of solution, 329.95 Kelvin. And the boiling point of pure acetone also they are given, that is 329.45 Kelvin. Calculate molar elevation constant. They are asking you to calculate the Kb. So, my friends, how to calculate the Kb? This is very simple things. You know the formula. What is the formula? Delta Tb is equal to Kb into W2 into 1000 divided by M2 into W1 in gram. Obviously, M2 into W1 in gram. My friends, you rearrange this formula in terms of the Kb. Therefore, Kb is equal to what it become? Therefore, Kb is equal to M2 into W1. Obviously, M2 into what? M2 into W1 into what? Delta Tb divided by what? Delta Tb. M2 into W1 divided by delta Tb divided by W2 into how much? 1000 if we are taken the W1 in gram. Okay. So, put the value in this equation. Therefore, Kb is equal to, what is the value of M2? The value of M2 is 152 into what is the value of W1? Value of W1 is 26.68 because 26.68. What is the value of delta Tb? You calculate the value of delta Tb like this formula, T minus 329.95 minus how much? 329.45. By using this we calculate the delta Tb, then divided by what is the value of W2? It is 1.21 into how much? 1000. So, dear friends, you calculate very systematically. After calculating, the value become, the answer of this question become 1.676. The value this become 1.676 Kelvin kilogram per mole. So, the remaining problem related to this point we will discussing in the next videos. Thank you very much.